Unit 3. Research Methods. Presentation 2. Experimental Design.
All experiments have an independent variable and a dependent variable. Let's consider an example of an experiment. We're going to investigate the effect of anxiety on recall. In this case, the independent variable will be anxiety and the dependent variable will be recall. In order to investigate this research aim, we need to operationalize the variables.
One group of participants could run on the spot while looking at a set of pictures, while the second group look at the pictures while standing still.
Running on the spot would create arousal, which represents anxiety, so we have operationalized the independent variable. And the dependent variable?
Afterwards, both groups have to answer questions to test the accuracy of their memories about details of the pictures.
This is called an independent groups design, because we are going to have two separate groups of participants. What are the two separate groups?
Those running on the spot and those standing still.
How could you do the same thing, but have each person take part in both conditions?
Do you mean each person first looks at the pictures while running on the spot and then looks at the pictures while standing still?
Yes.
I suppose we could do it on 2 separate days. So on day 1, we get the participants to look at pictures while running and then test their recall. And on day 2, we do it again, but this time the participants stand still while looking at the pictures. And then we test their recall a second time and compare the two results.
Indeed, and it might be a good idea to use a different set of pictures on both days. Otherwise, they might do better on the second day because it would be the second time they saw the pictures. If we do it this way, with just one set of participants who do both levels of the independent variable, this is called a repeated measures design. For independent groups, the weakness is that there is no control of what are called participant variables. The fact that the participants in each group differ in relevant ways that might act as extraneous variables. The participants in each group might be different. You might happen to have a particularly dim set of participants in one group who are not very good at remembering things.
So then, they don't do well at the recall task, and it wouldn't have anything to do with whether they were anxious or not.
This acts as an extraneous variable, a variable that is extra to the experiment. And this extraneous variable influences the dependent variable of recall when we don't want it to.
How can you deal with that?
Researchers try to control extraneous variables, and in this case they might use random allocation to assign participants to groups in a way that hopefully evens out the differences. For example, the researcher might put all the participants' names in a hat, and then draw out the first 10 and put these participants in the running on the spot group. This means that they shouldn't end up with all the dim participants in one group. Participants in each group will differ in all sorts of ways, but we are only concerned with the differences that might be relevant to the thing we are studying. Things like height or gender won't matter if we are studying memory, but intelligence probably will. There is also the problem that you need more participants for an independent groups design because you have to have two separate groups. But on the positive side, you don't get order effects, and you are also less likely to have a problem with participants guessing the purpose of the experiment because they only do one task.
And for repeated measures? They might get better at the task because they've had some practice. In fact, this might even be true even if we give them a new set of pictures.
Yes, that's a major problem with repeated measures. It's called the practice effect. Alternatively, participants might actually do worse the second time because they've got bored of doing a similar task. This is called the boredom effect, and both of these are examples of order effects.
Because they're related to the order of doing the tasks.
Researchers use something called counterbalancing. This is used to deal with order effects by ensuring that each condition is tested first or second in equal amounts. For example, some participants do condition A, then condition B, whereas others do B, then A. This is still a repeated measure design because each participant does both conditions, but just in a different order. And also the fact that participants might guess the purpose of the experiment. And on the positive side, you don't have problems with participant variables, and you also need fewer participants than if you did an independent groups design.
The weaknesses of independent groups are the strengths of repeated measures, and vice versa. So, what is a matched pairs design?
The third and final method of experimental design is when pairs of participants are matched on key participant variables.
What do you mean by key participant variables?
This is a similar issue to the relevant participant variables we discussed earlier. In a study about anxiety and recall, we don't need to match participants on height because that's not going to be relevant, but we might want to match participants on intelligence if we are studying memory.
So, with a matched pairs design, one member of each pair is placed in each condition of the study.
This means that, in a sense, you get the benefits of repeated measures because participant variables are controlled.
And you get the benefits of independent groups because the participants don't experience order effects and can't guess the purpose of the study because they are actually in separate groups.
The main weakness with a matched pairs design is that it takes a long time to find suitable participants and match them on the key variables. And even then, you might not match them on all significant variables.